Hello and welcome to Coffee Talk with Serge, the interview series. Take a load off from your busy workday and listen to the dulcet tunes of our guests, who are all over the cybersecurity landscape. We're going to ask them some hard questions, not going to lie, probably some softballs too. But no matter what, it's going to be a good time. So sit back, pour yourself a nice hot cup of coffee, or something stronger if it's that time of day, and enjoy Coffee Talk with Serge.
I love that intro that Ryan created. It just sets the tone perfectly. All right.
And in my head, I'm hoping for all the softball questions.
Yes. Well, I mean, I think softball in the terms of me just trying to understand certain things. So be prepared for those questions. But anyway, welcome to Coffee Talk with Serge. This is the interview series. Today we have Michael Haag on the show, and Michael is the senior threat researcher at Splunk, part of the Splunk threat research team. Very excited to have you on today, especially because there's a recent project that you just released that I'm looking forward to talking about. It's called the LOL driver project. So we'll get to that in just a minute. But first, I just kind of wanted to start it off with your background, really how you ended up where you are today at Splunk, and then we can kind of go more into what you do. So how did you end up in cybersecurity, and what other roles did you have before you came to Splunk?
Yeah. Thanks for having me. Yeah, I think I've been in the industry. I think I've been working in IT or security for about 12 years now. Started off doing PC support, fixing printers and fixing really old computers.
And you stuck with it, like fixing printers? You managed to stick with it? You didn't rage quit?
Yeah, did it for, I think, a year. It wasn't long. And then after that, I moved in. I got kind of lucky. There was a company not far from where I lived that was looking for like a new junior sysadmin, and I was, okay, let's do it. And so they hired me in, and I learned a lot about networking and just sysadministration. And at that point, we had a pretty big incident, and we had like a public web server get compromised, and the adversary installed a rootkit and all this cool stuff. And for me, I was mostly always focused on like IT system administration. And I was like, how did this even happen? Like, what does this even mean? And I got lucky. We had a security guy who we had a contractor come in, and he started explaining and showing me all these things. And then I just got curious and was like, well, this is interesting. And so, yeah.
Well, speaking of rootkits and Windows drivers as rootkits, right? That's something that we'll maybe get to in a second, because I am curious about how do you detect suspicious drivers? And that's one of the questions I hope we can get to here in a minute. But before we dive into this project, I wanted to talk about the Splunk threat research team and some of the work that you do. Kind of on a tactical level, right? Because a lot of the guidance that you provide, it's different detections and use cases. We have analytic stories at Splunk, which I guess are just use cases that are supported by, the detections that you create for using Splunk. What else how can people utilize this information that you're putting out in terms of detections with emerging threats?
Yeah, so I think to kind of start with like Splunk threat research team. So our team focuses on, generating security content for Splunk. And the idea is that we, whether it's an emerging threat or just a technique or tactic that an adversary is performing, we take that, we work to simulate it, and we give back to an open source project called Atomic Red Team. So everything we do, we can reproduce it, or someone else can go and reproduce it using Atomic Red Team. Once we simulate it, we use Splunk to, build our analytics for it. And we also dump that data, that attack data, and we share that to a project that we run as well, which is called attack data under Splunk's repositories. And so all the attack data goes there. So we share that to the community. And then the security content itself is shared on you could see most of it usually on our research.splunk.com site. So all of our content's there. And then typically we always simulate this within another project we have, which is attack range. You can kind of see our projects there at the bottom there. So it's, we simulate it, generate the content, dump the attack data, share all that out. And then our content itself ships out to a couple different apps. We have enterprise security content update, and obviously enterprise security. And then it also goes to the Splunk Security Essentials app. So
Yep.
a little bit all over. And then you can go and grab it from the site as well.
Yeah, and Splunk Attack Range, there's a GitHub repository with more information on that we can share, and then the data repository as well. So I'll make sure to get those links together too. But I also wanted to talk about, it's not only just these detections that you produce, but also blogs as well. There's quite a few blogs that the threat research team publishes, and I know we have a couple that we wanted to highlight that just came out. Let's see, this one is about certificate abuse. So what can people learn from reading this blog?
Yeah, so I got I was working another series with Windows, and I was digging into IIS, which is the next blog. But in particular with certificate services, I was digging into Spectre Ops's report, which is about 150 pages, and plus they have their blog. And I was curious, and towards the end of the PDF was like X amount of pages of detection, and so I was like, well, let's dig into this. And as I started digging into it, I realized there's a lot here. There's a lot of data that could be collected and put into Splunk or SIM and look at it from that aspect, and obviously new content that could be created. And so the blog kind of walks through, taking, what is a certificate store? How can I use Atomic Red Team to simulate adversary behavior to generate this type of traffic or this type of, TTPs or whatnot, and then take that and put it into Splunk. What logs do I need in order to detect this particular behavior? And there was a couple like nuances and things that Spectre Ops called out that makes, certificate service abuse like tricky or even hard. But also there's, at least we can get the data, and then maybe we could generate some content on it. And then, what you're seeing here is sort of like how I simulated that using utilities like Mimikatz. And again, all of this is an Atomic Red Team, so we try to make sure we can make it reproducible. So if someone was curious, they can go run the same thing and play with it from there too.
That's awesome. And I know we had another blog you mentioned, IIS Modules, I believe is the next blog that we have, and how to find them. So for people who aren't familiar, what are IIS Modules?
Yeah, so IIS is obviously Microsoft's web server application, and within it, there's two different types of modules. There's a native module and a managed module. And so adversaries have slowly over time been abusing IIS in a way where they will load up a new module inside of IIS, and it's extremely stealthy. And talk about drivers being hard to identify. IIS Modules is like right up there.
Yeah.
There was a couple reports Microsoft published, I think 2 last year, and then CrowdStrike published a really good report on a campaign they've been tracking for about a year. And it's just a very fascinating space with IIS and adversaries injecting these modules. And the modules can be used in tons of different ways. They can inspect all the traffic. They can, inject whatever they want to inject into it, and just standard persist on that server for a very long time, and most likely, going unrecognized.
Yeah. And I want to take a step back here for a minute too, because we did have a few comments on LinkedIn, I believe. So LaQuisha is asking what kind of credentials you had when you were only working on printers back when in your first job in the industry.
Yep, great question. I know we didn't finish all of that. So I was finishing up college on an associate's degree, I think associate's degree. And I had very simple creds back then. It was like MCSE, Microsoft Certified Systems Engineer, I think it was. And I had like, A+, Security Plus, Network Plus type based certificates. And I think, like everyone always says, certificates sort of just open the doors to, getting the interview or moving up in something. So a lot of those just basically helped me to move up from there.
That's great. Yeah, it's always interesting how I feel like getting your foot in the door is really the hardest part in terms of once you've already had that first job, then from there you just build. But really a lot of people, it can be challenging to find their in with cybersecurity. So, and tell me a little bit more about, so after you were working as a sysadmin, what are kind of the next steps that you took?
Yeah, sure. I moved into like a senior network security engineer role, managing a pretty small network that was a little bit global. We built a cloud application for medical devices so that like pathologists in the US could help, hospitals in China and things like that. So we built this large cloud infrastructure. And then from there, I moved to a Fortune 150, really large company. And that's where I started to like interact with Splunk a lot more. We built our whole like almost like our SOC or our service around it at the top. And at the time, I was a security architect, and so everything we did was in Splunk. It was really cool. We had a really large EDR infrastructure, and collecting 70,000 endpoints worth of data, and we were actually Splunking all of that data. And so it became a really big deal and very critical for us in Splunk. Um, and then after I left there, I went to a little company at the time. It was Red Canary. I was at Red Canary for 4 years and focused mostly on managed detection and response. And so we focused completely on the endpoint. And I think when I left, we had about 4 different endpoint products coming into the platform, and all of it was focused on just threat hunting through that data, finding new threats, and helping customers from there. And then I'm here at Splunk.
That's great. And when you were at Red Canary, is that kind of when you first started thinking about drivers and how to detect suspicious drivers, or when did that start to come on your radar in terms of something to look into more?
Yeah, back in 2018, we had an incident where this malware came in. It did a bunch of normal things. I think it was through WannaCry actually, and it came in. They installed a bunch of pretty noisy things, and then AV things caught it. It was kind of gone at that point. It wasn't until after the fact I was digging through a product, Carbon Black Response at the time. What they used to have like a process store and a binary store, and the binary store is really interesting to me because it shows what is actually on disk, what's on the endpoints, and it collected mostly everything. And so I was digging through the binary store, and I just happened to find this .sys file, and it just looked weird. And kind of to your question of how do you identify good or bad, it's kind of like luck with drivers in general. And so like it just looked super suspicious. Its path was weird. It's only on one endpoint. Why is it there? Like it just didn't make any sense for a pretty big organization. Like only place I've seen it. It's not on Virus Total. It's not, it's kind of like, where did this come from? And so that's when I got really interested. And it took us a while. We actually wrote a blog at Red Canary about drivers and driver inventory. Casey and I, we had really dug into it. And that's where I really got interested in, from like a defender's perspective, like how do I, like you've asked, like how do I identify malicious drivers or suspicious, and where do they go, how do they get here, and things like that. And so kind of from then on, I've always been curious about like drivers in general. And it's probably one of the toughest topics because there's not a lot of it's kind of it's a really dark space, and there's not a lot of light shining on it unless you're like a kernel developer or you are actually working with drivers day in and day out, developing one, or writing anti-game cheats or something if you're a game company and things like that. So it's kind of a weird spot from like a defender to be able to go after these types of things.
Yeah, but it is a method that's being used actively by, advanced persistent threats, right? Where they're in order to gain persistence, they might take advantage of a driver, like you said, maybe rootkit level types of attacks, right? So when you're talking about hardware, because a driveware kind of exists as that software interface between hardware and your operating system or different programs, that's where it can really be tricky if someone is looking for long-term persistence, for example, of using a driver in order to achieve that. So I wanted to talk about this project that ties in perfectly with all of this, the Little Drivers project. And this is something that you worked on with Jose Hernandez, who formerly at Splunk on the threat research team, and now I believe he's at Laceworks. And so this is basically like a centralized list of known vulnerable or malicious drivers for Windows drivers. And I guess kind of tell me about this process when you decided to start compiling this and providing kind of a centralized place where people can find this information.
Yeah. So last year at the SANS D1 Summit, I did a talk, and it in particular was all about hunting drivers. And I framed it as, if you look at the title of it, it's kind of cool. I really dug it because it just reminds me so much of having a hard time. It's titled "Hunting Windows U-Boats with Cyber Depth Charges," and it's like hunting submarines for drivers. It's like, I'm just going to dump a bunch of things into the water, and we're going to hope that we hit the submarine that's way down there. It's very much like hunting for a sub when it comes to finding drivers. So after I finished that talk, I have a slide in there which has like all these resources, and I probably say it very similar to this, which is, go check out these sites and you'll find, all these malicious or suspicious drivers. And there's like the Microsoft's block list, and there's FizMem, and another resource from Eclipsium, and it's just links. And it's like, okay, that's cool. But I started thinking after, which is, we don't have, as a defender, we don't really have a place to go to see all these in one location. And so a couple months after I really started thinking about it, I was like, we should create a site that has all of these drivers in one place. And just something as like organizational defenders can go and, if you're looking for like a CSV list of them, we have a Sigma rule you can download and convert to, any SIM product. There's a giant hash list that you can find here. And typically you can't find these on even those resources that I mentioned. Microsoft's hash list is very different from the FizMen hash list. Well, combined, we created a YAML schema that now all of these drivers in one place can follow, and we're able to, describe it. And if you click into any of these on the list right here, you can easily see, we were attempting to enrich them so that there's a lot of data that is provided to anybody viewing the site. And I think on right now there's about 270. Yeah, it's a lot of data, and these are known vulnerable drivers, and I've been trying to add in what I call malicious drivers, and those are like the adversary based ones, because adversaries do use them. They either steal a certificate, like what we saw with NVIDIA, to sign malware, or potentially to sign like a driver, things like that. And so adding malicious in there's a couple other categories we plan to add as well, just to expand it out more. But yeah, it's a really big project, and I'm really happy with it.
Yeah, and this is something that's also kind of open source, and people can contribute. If they're looking at the list and they see something's missing from it, there's actually a form that you have. It's a Streamlit link that I will share in the chat, where you just fill in the blank, and it creates a YAML file so that you can add to this project. And I'm kind of curious, are there any additional bits of information that you're looking to add to each of these different drivers?
Yeah, so the form here, you can fill it in and it'll produce the YAML at the end. And it allows, anybody to go and create this, copy the YAML, submit a PR. And the idea was always try to make the barrier to entry to providing new content very simple. I didn't want this to be hard. I didn't want it to be like some 10 different tools you have to use to use it. Right now on the back end, Nasruddin and we've been working on providing an enormous amount of enrichment to each one of these drivers based on the hash. Enrichment meaning the authenticode hash, all the certificate data, as much metadata from the binaries as possible. And that's going to help fill, like what you saw on the first page, that'll help fill in like the pie chart and all that cool stuff like that for reporting and everything. And of course, it'll come down in the CSV format if you want to play with it that way too. So,
yeah, and I guess, this is great to have kind of a centralized space to find this information, instead of trying to pull it from all these different sources, and not having that sense of visibility, right? Like if you're trying to do an inventory of the drivers that you're currently using, that it's really critical to have this one source. So I'm curious, for anyone that's hoping to utilize this, what are some examples of being able to take this information and then apply it to your environment to get a better sense of what drivers you currently have, or maybe if something's being loaded, and tracking that to see if there's something suspicious?
Yeah, great question. And so I think the idea, I think a lot of folks will initially take it, maybe create a lookup, like if you're using Splunk, and an attempt to just find like the known hashes in an organization. But ultimately, I think with drivers in general, it's doing an inventory, collecting them somehow, whatever, if it's through like an EDR tool or a collection method, another product you have for inventory, inventory them, look at it based on the counts and based on file paths. And the hardest part is digging through like the actual like signing data and the metadata of the binary itself. But looking at all that can lead you to understanding what should or should not be in your environment pretty quickly. It does take a lot of time.
Yeah.
I think that's where the cost to value on something like that comes into play.
Yeah, but like you said, this is kind of an area of, network defense that's not as covered, not as frequently discussed, but it's still important. So hopefully this project will help shed light on that as something to be aware of, right?
Yep, absolutely. And yeah, like I said, there hasn't been a place where all these different lists have never been put into one place. Have a simple YAML schema, and you can easily traverse it and look at it and use it. I see a question about an API. There is an API for it. We do have it in like JSON format, CSV, and everything too. Yep, you can capture it all there.
And then another question we have is why stop at Windows? What about Linux, Mac OS? Is there any plan to expand this?
Yeah, I definitely wouldn't deny a PR for any Linux and Mac stuff. We talked about it originally, but I think kind of our initial push was getting just the Windows stuff out because we had it collected and ready to go.
Right, right. That's great. And I also know that you had a SANS talk about this, which I will go ahead and share in the chat as well. And this was kind of about hunting for drivers that were used to basically facilitate kernel level persistence, like we were talking about before. And I know you go into that and you kind of talk about, inventory, and I think you also talked about Windows attack surface reduction rules, driver signing, which is something I'm interested in learning more about, like driver signing enforcement. Like, is that something that's really enforced, or are there still quite a few drivers that are unsigned? Like, how does that work?
It's hard. It's easy to say that Microsoft prevents all of these things, but in reality, in the real world, I feel that what I've seen and what most people will find in their environments is that the backwards compatibility with Windows is like a mess. And that's the simplest way to say it. Is there's so much backward compatibility even with software and applications that having all these things on there and installed to prevent this, it doesn't always happen that way. And so I've seen unsigned drivers load up on Windows 10, 7, and everything like that. So it's hard to believe that it's always going to be like this perfect place in prevention. And I think that's where the driver inventory really helps. As hard as it is and hard as an inventory can be for drivers, it's definitely one of the most important things that you can do for getting started on looking for them.
Yeah, and I remember from watching your talk that I just shared, the link you mentioned, I think it was 32-bit drivers are typically were unsigned in the past, and then that changed right around like Windows Vista timeframe. But you could still see potentially if it's a 32-bit driver, it is likely unsigned from the past, is sort of what you've seen before. I thought that was interesting. I didn't know that. And I also I saw some of the searches that you mentioned in that talk as well about how to monitor for like a new registered kernel mode driver, event code. I think it was 7045, event code 6, which is a driver loading, things like that you can search using Splunk, for instance, in order to monitor for new activity, look for new like sys files, things like that. So it's a very, very good talk. Highly recommend listening to it if you're interested in learning more about detections and monitoring for suspicious driver activity. Another question we have, any thoughts on the recorded future AI announcement? I did see that earlier. It's about using AI for threat intelligence. And I haven't looked into it enough to form an opinion. I just did see the announcement earlier today. I don't know if you had thoughts about that.
I haven't seen it yet.
No.
I'd have to check it out.
Yeah, it is interesting. And I know a lot of companies right now are looking into strategies in order to incorporate AI into their products. So it will be interesting to see who follows suit with this and if it becomes a new trend and how that would play into AI, especially with biases, because artificial intelligence has its own issues with bias and threat intelligence has its own issues with bias. So anyway, that's my take on it. But back to drivers, getting a little distracted here. I also wanted to talk about a show that you host on YouTube, and this is called Atomics on a Friday. I know your latest episode, we talked about the Lowell Drivers Project. But this is a show it's on YouTube every other Friday at what is it, 1 o'clock Eastern? Is that right? When people can watch it?
That's correct. Yep.
And so I guess tell me a little bit about that, what people can expect, what kind of topics you cover.
Yeah, sure. Atomics on a Friday was born out of, there's like a kind of a niche spot of, helping defenders or even new people come up in the space of like detection engineering and simulating like adversaries. And that's where Atomic Red Team's at, right? So the simulation. And so Atomics on a Friday kind of fits in the spot of let me simulate this and then let's talk about how to detect it. So it's very kind of like detection engineer focused, and Paul and I, we love it because it gives us the chance to showcase, all the different types of atomic tests that are out there, or even have like special guests come on and share, something that related to detection engineering that they perform. And, we talk about detection and how that fits. So yeah, that's kind of the short spiel of Atomics on a Friday.
That's awesome. Yeah. And so it won't be this Friday at 1, it'll be the following next Friday at 1 o'clock is when your next show is. So mark your calendars. That's when you can tune in, or I guess you can watch it at any time because it's on YouTube, but that's when it's live.
Yes.
Yes. Okay, great. I wonder, is there anything else you wanted to talk about with the Lowell Drivers project? Anything that I didn't ask that you wanted to mention?
I think we covered it all.
Perfect. Well, thank you so much for taking the time to talk about this. It's something that I honestly did not know much about walking into this conversation, and doing some research beforehand. It was really eye-opening to see, how drivers can be used by adversaries, and then also what you can do to try to track that and detect suspicious drivers. So I think this project will be very beneficial for a lot of people. So thank you for putting it together, and keep us posted if there's any updates, anything new to share. Yeah, and I'll make sure to add all of the links that we talked about in this show to the description, probably in the next 15 minutes or so. So if you want to look more closely at any of it, just check back and we'll have all that information. So with that, we'll go ahead and say goodbye. And again, thank you so much for taking the time to talk.
Yeah, thank you. Appreciate it. Thanks for having me.
Surge.